algebraic expressions with fractions and factorization. In this example, we're looking at a basic plus and minus fraction. So when we have the plus and minus, remember, your focus is to obtain an LCD, a lowest common denominator. As you can see, they're all different here. So what you need to try and do is standardize it so that we can obtain an LCD. So I'm going to factorize all of the components in the numerator. X squared minus 16, that is a difference of two squares. X plus 4, x minus 4. And in the denominator, there's a common factor of 5. Extracting that leaves me with x minus 4. In the next one, this is trinomial factorization. So our two brackets. X times x, and a pair to obtain the product to 2, but the sum to -3 is 1 and 2, where they're both a minus. And in the denominator, I'm going to extract 3 as a common factor, leaving me with x minus 1. And in this one, all I'm going to do at this point is to simplify the fraction 4 and 2. So if I say 4 divided by 2, it's 2. And the denominator 2x squared divided by 2 is x squared. All right. Looking at the monomials within this polynomial, here I see an x minus 4 and an x minus 4, which I can cancel. The reason I can do that is because isolating that term is a monomial. So if there's something present in the numerator and denominator, you can cancel it. In this monomial expression, there's a x minus 1 and x minus 1, leaving me with the expression x plus 4 over 5 minus x minus 2 over 3 plus 2 over x squared. At this point, we want to establish the LCD. So what number, or what can 5, 3, and x squared all fit into? The LCD is their product. So that will be 15x to the power of 2. I like to do it over one big denominator instead of writing it as 3 individual terms. 5 to 15x squared. I'm lacking a 3x. I need to times this by 3x to get here. So I take the difference, which is the 3x squared, right? 5 times 3x squared is 15x squared. And I need to multiply that by the current numerator. Same here. 3 to 15x squared, I need a 5x squared, which I'll distribute with that existing numerator. Plus the 2 needs to distribute with 15. Because to go from this denominator to this one, I need it times by 15. Okay, now we can simplify. I'm going to apply the rules of distribution. 3x squared by x is 3x to the power of 3. And this one here, 12x squared. Taking it here as well, distribution, 5x squared times x is minus 5x to the 3 plus 10x to the 2 plus 30 all over 15x to the power of 2. Simplifying your like terms, 3 of these x cubes, and I'm taking 5 of them away. These are the like terms, leaving me with minus 2x to the power of 3. Yeah, I have 12x squared and 10. So that means I've got 22 of the x squared terms. And then I have the constant 30. All over 15x to the power of 2. Now you can leave it like this, or we can apply the splitting property to simplify it within the monomial terms. So the splitting property says you can put minus 2x to the power of 3 on 15x squared, separated by the term here, plus 22x squared over 15x squared, plus the 30 over 15x squared. Now, within this monomial term, x to the 3 and x to the 2, I can get rid of a x to the 2 in both. So if I scratch out x to the 2, I'm left with 1 or something that doesn't need to be written. And then x to the 3, if I remove x to the 2 from that, I'm left with x. In this expression, x squared and x squared present top and bottom, so they can be removed. And then between 30 and 15, 30 can be divided by 15, right? So 30 divided by 15 is 2, while 15 divided by 15 is 1. So you needn't write that. The final answer, I'm just going to squeeze it up here. We've got minus 2x over 15 plus 22 over 15 plus 2 over x squared. Okay, so it is acceptable for you to leave it at this point. However, if you do see potential within each term, you can apply the splitting property so that there's no further simplification that needs to get done. Another one involving plus and minus. We start off by factorizing the separate parts. Amongst the first numerator here, there's a common factor. So if I pull x out, right, what am I left with? X minus 4. There we go. And in the denominator, this is a difference of cubes. So how we do that? You start off with a small bracket, which is the cube root of each term. So that's x minus 1. And then the second bracket is a big one by taking their squares. X squared is x raised to the 2, and minus 1 squared is plus 1, and the middle term is their negative product. Minus 1x, so that's plus x. Plus 1 over x minus 1, there's no factorizing there. And then this denominator is trinomial. But a trinomial which we are not able to simplify at this point. Because looking at the 1 here, there's no way we're going to obtain a 1 in the middle as the coefficient. So for now, let's just leave it and see where it takes us. Okay. Within each one, I don't see cancellations possible. In this monomial, no cancellations, no. So now we are going to proceed to get the LCD. The LCD, as we can see, there's a x minus 1, there's 1, and then this trinomial and this one. So the new LCD is x minus 1, x squared plus x plus 1. See what each numerator lacks? This one is perfect. The denominator is exactly the same. So we can keep the x by x minus 4. Over here, plus 1. Notice that the denominator lacks the trinomial. So you've got to distribute it with that trinomial expression. And then this one here, the plus 2, it lacks the x minus 1 component. So that's what you're going to times by. Now that we can see all of that, see if we can simplify this expression using distributive methods. X squared minus 4x plus x squared plus x plus 1 plus 2x minus 2. Now you're probably wondering, why did we factorize in order just to distribute it back? Remember, you first want to factorize to see if there's a possibility of cancellations in monomials. Because that wasn't possible, we now had to resort to distributing out. Like terms, here's an x squared and an x squared. That leaves me with 2 of those. So I've used this, I've used this. Then my x terms, I have minus 4x plus x, that's minus 3x, plus 2x. Minus 3x plus 2x is negative x. So I've used u, I've used u, I've used u. And then my constants 1 less 2 is negative 1. All of that over x minus 1, x squared plus x plus 1. Let's see if this trinomial is factorizable using the T1C approach. Just going to do that on the side as workings. term 1 constant. Term 1's pairs are 1 times 2 or 2 times 1, while our constant is 1 times 1. Doing a cross multiplication pair, 1 times 1 is 1, 2 times 1 is 2, and I can obtain the negative 1 if that's minus and that's plus. So now I'm going to just translate the signs into the brackets. The minus 2 came from this term, and the plus 1 came from that term. All right, I have everything I need now. So the numerator becomes x minus 1. And then the second bracket becomes 2x plus 1. All over this expression here, which is x minus 1, x squared plus x plus 1, which is a monomial. And look at that. There's an x minus 1 and an x minus 1, leaving me with this expression right over here. We established that this trinomial wasn't factorizable by inspection, so you are welcome to leave the sum like this. 2x plus 1 over x squared plus x plus 1.
If you've enjoyed this video and you've learned something from it, you may want to check this one out next. A like and a subscribe will help us to grow our channel, and feel free to share this with any of your friends so we can all achieve academic success together. See you in the next one.